Great. I've shared the screen, so hopefully everybody can see that.
Yes, perfect. Everything works. And yes, so you can start then whenever you feel comfortable with, but I think 12, yes.
Okay, well, I'll make a start. So I stand between you all and your lunch, so it's always a dangerous place to be, between somebody's lunch. Good morning, well, good afternoon, actually, in your time. I'm calling you from the UK, so wherever you are in time zones in the world, good day to you. It's a delight to present to you and meet you all here. So I'm Justin Edwards. Just scroll on, just bear with me when I just get this to move on to the next slide. I'm Justin Edwards. I'm the Director of Learning Programs at Minecraft Education Edition. I have responsibility for all the learning content, educational content, policy, assessment, research, and community work that happens with the Minecraft brand in the education space. I don't know how many people on the call are Minecraft players or have played Minecraft, or have somebody who in their family plays Minecraft. It's hopefully a very popular game and you're all fully aware of it. Just to give you some ideas about the game, there's actually 3 versions of Minecraft. There's a Java-based version, which is the original version that came out of Sweden. There was a version then called the Bedrock version, which was developed by Microsoft out of Redmond. And then there's a version called the Education Edition. And this is primarily aimed at K through to 12 education, but it's also used in university teaching environments. And we've seen a lot of higher education teaching environments use it as well. It's available really to about 35 million students around the planet at this moment in 109 countries. So it has massive reach and massive scale, and millions of young people particularly use it every day in the learning context. And it does feature some of its worlds, and some of the work that we do in the Education Edition are also available in the Bedrock Edition. So what we find is a lot of children, particularly as part of the pandemic, tended to download the worlds that we were producing to continue their education. And there are 200 million users who use the Bedrock version. So it, again, from an educational standpoint, has enormous reach. We also have a version in China. It's a slightly different version in the Chinese market, and that has coding inside it as well. I joined Microsoft and Minecraft at the beginning of May. My previous job was actually Chief Executive of a curriculum and awarding organization. I worked for the UK government. I did curriculum advice and examinations advice and prometrics with inside the UK for about 7 years. But I've always had a keen interest in game-based learning, and I've always had a keen interest in coding, particularly coding in upper elementary and kind of middle school development around the world, and I've developed qualifications and written various books on how to take forward coding. And I joined Minecraft because I just have a passion for game-based learning and what game-based learning can do in education. And this is one of my kind of favorite quotes about why game-based learning approaches actually work. The fact that games just actually allow failure to happen, and failure is actually encouraged as part of the learning process. And we actually build in failure into the games, and we would describe it in a whimsical way. So if you fail, it actually creates comedy or smiles in the children, and then they just re-engage in the content over and over again in order to develop their understanding of the topic or the subject. And in Minecraft, we have a lot of kind of brand rules to keep that safe as well. We don't allow guns in the game. We don't like political identity. We don't have flags in the game. We constantly try and keep it safe, so that children are safe from that outside, but they can focus on the learning on the inside in this kind of fail-safe way. And it's gone from strength to strength with this particular approach. And we've taken a view in terms of what we do in Minecraft education to develop a broad range of future-ready skills. And I'm sure you're all aware of kind of the 7 C's or various versions of kind of 21st century learning and how that impacts. But we're really keen on games trying to hit as many of these topics simultaneously as possible whenever we build a game. So we're always conscious about building in multiplayer capability and collaborative education. And one of the things we've done from a coding perspective and computer programming perspective is to allow multiplayer coding. So we've just done work with Python. In the game, you can actually code as a team on Python script and build out solutions to problems and exercises like escape rooms. I'll show you a little bit more about that. Communication, so we're very keen on children working together to communicate their ideas and their solutions, and I'll show you how that's working. We're always keen on creativity, so getting artistic or model building inside our game to try and inspire that, as well as critical thinking. We've done a lot of work on cross-cultural. We've just finished off a piece of work called Good Trouble, which looks at kind of inclusion and diversity within inside game, and I'll talk in a moment about how we've linked that to coding and immersed that in coding and why that happened. Obviously, computing and computing is a big part of the game. We support MakeCode, Tinker, and Python, and Azure Notebooks version of Python. So we actually have full Python 3 installation, and we keep that constantly up to date on the computing side. But we also do logic coding, data, and we are also working on cybersecurity work as well in terms of developing in the game. And then we're constantly trying to build this idea of self-resilience. So how do we build in kind of failure into the game that's then supports learning and develops the understanding of the content. So I'm just going to focus, I could focus on the millions of hours of kind of gameplay that we have, but I'm going to focus on the code builder element that we use within inside the game. So Education Edition has one distinct difference from the other versions of Minecraft in that it has a coding engine built directly into it. And that coding engine, as I said before, it supports block coding through MakeCode, and children can switch from MakeCode to MakeCode Arcade and be able to test out code in there and come back into the code builder element. We also support Tinker. We support JavaScript as well, although the JavaScript element doesn't get used very much in terms of gameplay that we've seen, but it is there, and we find it popular in some countries. And then we support Python. And the script language you can actually switch between. So you could start coding in MakeCode, and by the flip of a switch, you can actually see your MakeCode transition to Python, and you can understand the Python link. So it helps block to text transition within inside the game and within inside the same context. We've also introduced this this little character you see on the screen here called the Agent. So he's a unique character to the Education Edition, and he appears with a block window. So a bit like Logo in the 1980s, you can actually instruct him to do things. You can change the world and all its mechanics with the code, but you can actually have this character. And so we use him an awful lot to, or her, depending on how you want to put it, we use the character an awful lot to help children interface with the world and complete tasks and complete actions. And since he's been introduced, he was introduced in 2019, we've seen not only development in kind of elementary work, but we've actually seen university students in postgrads building AI interfaces for this character. And he tends to then, automate tasks around a virtual world and do all sorts of stuff, or even replicate or even build. So we're actually seeing applications of this in HED right the way through to elementary work as well. And with this little character, as I mentioned before, we have this kind of pathway where we're working with block code on elementary and middle. We progress then to the intermediate where we introduce the JavaScript and the Python, and we allow this transition so you can switch back and forth between the coding and see how your coding will change between the different formats. And then we have advanced Python work all the way up, as I said, to actually being able to support quite substantive elements of code right the way through to ML and AI. We have, it says there on that screen, we have 150, we've actually built some more. So we're about 200 hours of learning content now on CS. And we break it up into different layers. So we do have AI lessons that are for middle school students and understand the kind of concepts and ethics of AI while completing coding courses. We have coding fundamentals. We have computing with Minecraft that understands basic theory of computer science. And then we have some very, very dedicated specialist games, like we have Museum Heist, which was based on Wonder Woman. So we did a partnership with DC, and Wonder Woman comes into the game, and you help Wonder Woman solve problems inside a game by coding with the agent to help her. So we make it very relevant and very current to the learners so that they can actually enjoy characters that they're seeing inside game and interface with them. And then we have programs like Seymour Islands, which takes about 3 hours to complete, which is actually multiplayer, Python-based coding escape rooms. So escape rooms with cryptography and puzzle-based learning inside that. The problem we have is that we've now developed so much content that it's actually got quite complex for teachers to navigate. So we're currently working to simplify a pathway of a single strand of learning of about 60 hours. So you can take a child from elementary code base right the way through to the Python islands and the AI work. So I wanted to talk to you a little bit about some of the impact we've seen since we've introduced it into the classroom. Like I said before, 109 countries around the world, we've been using this in coding, and we've just seen it grow and grow all the time. I think that during the pandemic, we saw an absolute huge explosion of Minecraft because the licenses and the activities were already in the schools. But what the schools realized is that with remote learning and distributed learning, they needed some application that students were familiar with in order to continue some of the coding elements. So Minecraft really took off in kind of the Minecraft education. The coding really took off in March 2020 as part of that interaction and reaching across all the age ranges. The other decision that we made, which was different from Bedrock, is that we actually deploy on Chromebooks and Android devices and iPads and MacBooks. So we recognize that children were using all sorts of devices out there, and Minecraft really shouldn't be limited to a small number of devices, but should reach out. And today, about a third of the coding gameplay actually takes place on Chromebooks, and the Chromebooks have become more established post-pandemic. And I think that during the pandemic, people saw them as a solution to continue to activate kind of CS coding during that time. And so we saw a drive into that work. So these are just schools and teachers around the world, obviously using the education edition. So I'm going to tell you a little story about cross-curricularity in coding and lessons we learned from the children that helped us change the model of approach that we took. This is a castle in Wales in the UK. And I haven't chosen this because I'm Welsh. I was actually born in Wales, so I was born in this part of the world. I've chosen this because it was a fascinating project that happened. We found that Minecraft is really popular in Wales, and it's really popular with rural students particularly. And there's a lot of projects in Minecraft that tend to happen, particularly in the elementary phase, which is kind of understanding history and building out castles, because Minecraft has that kind of medieval feel to it. So a group of teachers across schools in North Wales have got together to do a Minecraft project on this particular castle and to start building it. And the students were really interested in learning more of their kind of local history and culture. And this is Harlech Castle that they built out. So they started understanding about the castle and how it was built and its history and its construction value and how it kind of degraded over time and what different features of the castle were. And they once they'd done that history, they planned to start building. But the building, because it was a castle, was going to take an awful lot of time. And the teacher was just very keen that they would build this out. But the students actually themselves went off and discovered about block coding inside Minecraft, and therefore decided that instead of just building it themselves. They'd understand the architecture in terms of 2D and 3D graphing. So this is the students actually did this directly. And then they engaged with the Minecraft block coding element and started building through code the castle. So instead of building the castle block by block, they actually started taking their own particular features or particular biomes, and I'm just going to show you here, taught themselves the block code, and then programmed the agent, and the agent started building the castle itself. And then the students started working across GitHub, and these are 8 to 10-year-old students, started working across GitHub to share their code on how to build a better castle. So this was a video taken by the teacher at the time of one of the students working on their own, and without any interface from the teacher or any interaction from the teacher, the child had actually built this code that once you type castle, away the agent went and started building Harlech Castle directly from block code. And this is what we found consistently with Minecraft. It kind of stimulates immersive learning. There's a kind of drive in the gameplay that is driving learners to study the code without necessarily with educator support, but actually kind of self-driven aspects. This would take ages to build, but it does by the end of the day. I can assure you, build Harlech Castle. And so we found that this kind of cross-curricularity theme was a big part for the learners when we asked them. It was understanding place and then applying code in context. And mixing the two together was really, really important. And this got us thinking about, so what do we do with our coding content that brings this cross-curricularity to life? And so in the early part of 2020, we launched a thing as part of our code, a game as part of our code, which was called Tale of Two Cities. And the idea was that there were two tribes, villagers and illagers. They exist inside Minecraft, and they wouldn't work together. And the only way you could get them to work together was actually through coding. And you could do it in block code or Python code. And we took a risk because really you're trying to include kind of equality and diversity. This is the video that we made just to launch it. You're trying to include the ideas of kind of equality and diversity and community and working together. And you're trying to throw computer code in the middle of it. So we didn't know whether children would buy into it, whether they would see it as kind of a place where they would go. And in the space of a month, it had 13 million downloads. It just went absolutely huge, and even today, children still download it for about 45 minutes of playing. So we're doing something again similar this year. We're about to launch in November another version of this called Arrow Code again, and this one is this year's one's going to be about time travel. But again, you're going to visit places and people in history and actually code in those contexts. So by coding in context, what we're doing is really moving it away from the idea of just coding, but coding with purpose and coding with application. We've of course mapped all this work to various standards. So we do use Digicom, we do use CSTA standards, and we're making sure that what we do meets those standards, but we don't put that up front for the learner. What we do is we put the gameplay up front and the ideas of inclusion or the ideas of time travel and place up front, and the coding comes behind, and then we let the coding explore. One of the other things that we're trying to do this year is try and include repetitive gameplay. So actually, the more you code, the more features come out of the game, or the more rewards come out of the game. So it encourages that idea of the Harlech Castle in Wales for the children to go off and learn more and come back and apply it in repetition and develop their skills further. And this is just some short video in game, so you can see you can travel to the villager side or the illager side of the game, where there are two cities, and you go and meet various characters within the village who all have problems or perceptions about the villagers or the people who live on the other side of the river, and you build code then that actually starts to bring them together. And slowly, as you build up your code portfolio or you solve problems through code, the villagers and villagers start to build bonds, and they start appearing in each other's villages, sharing code and sharing ideas. And so you start to break down the kind of barriers between the two cities, if you like, and eventually everybody's working together on the basis of code. And as I mentioned before, we did this on Block or Python so that we could actually appeal to different age groups simultaneously, or on the transition state. And then, like I said, we saw huge downloads, but really for us, does it make a difference? And the evidence from educators, from practitioners, is overwhelmingly yes. We have an awful lot of qualitative evidence that people talk about. Minecraft kind of inspires and engages depth of learning, that it is making a difference to those students who were otherwise disengaged with this type of content, and it reactivates them. We are working with research institutes to go and get more quantitative impact measures and to understand in metric terms why this happens. We know it does happen, but why it happens. I think for me, it's continually the posting of smiling faces on Twitter that we're seeing, that we know it is making a difference, and it is making a difference in 26 languages we're currently running in. So we know it's not just a basis of English only. So hopefully that gives a sense of how students in the classroom practice influence actually how we develop gameplay, how gameplay can actually in coding be multicultural, diverse, can create different interactions as well, and that really we're finding a lot of impact and a lot of change by involving game-based learning in the coding arena. And Bernadette, I'm happy to stop there and take any questions or any views, and just leave the time for extra chat.
Great, thank you very much. You were just right in time. Yes, and it was great to see such comprehensive picture of the work at Microsoft for Minecraft. So thank you very much for that. And also it was great that you see that you put a focus on diversity. We had this, we talked about that also in the morning. So very important, and also that the youth already see what are the important things here. Okay, so are there any questions from the audience?
Yes, I've got a question. Where do I find the German version of Minecraft Education?
Yeah, if you download it from our website, German's actually built into the game. So if you set your game settings to German, all the worlds support German language. And then we support all the materials within inside the content in the German language as well.
All right, so okay, that's very nice. I was looking on the homepage and I couldn't find any. When I went to the Minecraft Education homepage, there was no hint or indication that I can get those contents in German as well. So yep. Maybe you can put it on there somewhere that you can get it in other languages. So
okay, thanks. We just switched over our website recently, and we're having to turn on the what we call the localization links, and one of those is for the language supports, and particularly German. But the game, if you download the game as it stands, and I've posted the link to our homepage there. The game as it stands supports German in the settings. So if you operate Windows, it'll pick that up and it'll play the game in German for you.
Perfect. Thanks.
No problem.
Okay, Wolfgang, do you have a question?
Yes, thank you first of all for this very nice talk. Very interesting for me as well. Regarding the languages, I also want to ask a little bit more here, because in our case, we also have kids from many different regions, and they introduce, of course, description, names of the projects, you know, the variable names, everything is localized. So for German kids to read the Russian or Chinese programs is a challenge. So we introduced recently the option to show all the strings in their own language. And this is, I think, something that helps. What I'm wondering is, do you know, because Python usually, I mean, I know there's a Chinese version of Python, but usually it's written in English, right? So do you have any split up in statistics, how many kids use the block-based localized language versus the English language versus Python?
Yeah, I mean, broadly, off the top of my head, we find that the make code and the block-based is more popular than the Python on balance. I think that's because we have more content in the make code element, but also that there seems to be some dropout in the transition between the make code and the Python overall. But I think that's kind of common with what happens in the learning context around the globe anyway. In terms of language, overwhelmingly popular is coding in English. We do have a, you're right, we do have a Chinese version. We have Chinese block and Chinese script. The Chinese version is separate from the main version of Minecraft. It's kind of just because of the way that we have to deliver in China. It's a separate application, so it's difficult to do comparators to the other language usages. But about 80% of the work that we do is in English. So it seems that the English is overwhelmingly popular for both the block code and the make code. I'll post the languages in the chat that we support. We currently support 26 languages for the game. For the lesson content, we also support Arabic, and we don't support Arabic in-game at the moment because we don't support right to left languages, but we're looking at that development.
Thank you very much.
Thank you.
So are there any other questions? Please feel free to ask.
Yeah. What about the sharing side? How do kids exchange their projects, or how is that? Is there some platform where you can show off the project? So
one of the other features we allow in Education Edition is you can export your world, your Minecraft world, and you can share that with other children. So if you build a world with a coding element inside it, you can share that within a group. You can also invite up to 40 children to work on the same world together in the Education Edition. We don't allow server-based play. We allow it in a controlled environment for child protection reasons with our product, but 40 children can log on to the same world and build and code at the same time simultaneously within inside that world, so you can have collaborative code. We also allow share out of the specific script or code so that they can, as I pointed out before, that castle in Wales, they were actually posting their script ideas on GitHub, commenting and then resharing back into game. And we also allow the worlds to be taken from the game and deployed on websites themselves, so you can actually save the world file out and bring it back into the game. So there's lots of sharing and collaboration opportunities that don't exist in the main game. The other thing we do is we don't, in Bedrock, in the main kind of commercial version of the game, they encrypt the games. We don't, so you can actually reverse engineer if you want to code in elements within inside the game. So we're encouraging open source collaboration at that point as well.
Great, thank you.
Okay,
I should have mentioned as well that, you know, my background is the chemistry set, so we actually have all the elements of the periodic table in Minecraft, and they all interact with each other, and you can actually code around them as well.
Great, thanks. So we have time for one more question. Is there any question from the audience left?
maybe about gender distribution. Do you know anything?
Yeah, we tend to find a very balanced gender distribution from elementary into middle school. We retain the gender balance in terms of kind of creative arts within inside the game, because we do kind of language literacy and art building and exploration of kind of social and emotional topics within inside our content, not just coding. But coding, particularly on the Python element, we understand because we don't record the data of the gender of players, but we understand from teachers that we tend to find disengagement. It tends to go more male bias as we progress into the upper years. But again, I don't know if that's kind of gameplay or if that's related to other things that are happening inside the education setting or in the gender setting anyway. But like I said, we don't hold data ourselves, so it tends to be kind of anecdotal feedback from educators.